Okay, good morning. Whoa, a bunch of people. I better get busy. Okay, I got Felix, Matthias, and Kai. Matthias, Felix, and Kai. I've got Liam, Aaron, Stella, Corsine. I've got Corey, Sina, Paul, and Lauren. I've got Ayala. I've got a person I recognize. Amelie. Okay, I got Ayala and Amelie. Okay, Amelie and Ayala. And I've got Anton, Jack, and Malta. Jack. Anton, Malta. I've got Isabella and Kiara. Isabella. Is here. Kiara. And, ooh, you're coming quick. I think I've got Isaiah and I've got Clara. Thanks everybody for showing up. I'm just catching up on you. Yeah, it is Isaiah. Thanks, Isaiah. I got Timothy P. I've got Ingrid, Zach, and Linus. Ingrid, Zach. Good. And I've got Devante. Good. Good. I'm going to call off some names just to see if you guys are here. Okay. I still am looking for Leo. I'm looking for Isaac. What's almost here? Still looking for. There's Isaac. Okay, good. Looking for Inessa. Did I miss her? Alessandra. Cassidy. Alicia, Aslan, Hannah, and Ethan. Any of those here say hi. Alessia, Tim, Hartling, Sophie, Avram, Allie, Julius, and Charlotte, and Michael. Julius is here. Good. I'll start up in just a second. With 2 classes, it does take me a while, doesn't it? It's a lot of you. Appreciate you getting up so early. I couldn't make it later in the day. Ines is here. Thank you. So I couldn't plan it later in the day because I've got stuff going on at school. A meeting there. Anyone else here? Okay, I'm going to set that aside. That's interesting. Alessia, thank you. You are here. Good. Okay. I think I might know the problem. Let's close this other one. Okay. I had a live stream I tried earlier and it didn't really go, so I just turned that one off. So maybe that was part of the problem, Alessia. So now there should be one live stream. Hope everybody else can find me. And they have. Good. There's Alessandra and Leo. Thank you. Super. And let's see if some others show up now that I turned the other one off. Technical challenges. And we'll see what's going on. Okay, I'm going to put these aside and let's begin for the day. Okay? All right, so here's what I'm doing with you. I'll leave that here. We're going to talk about doing drawings with intermolecular forces, how to show things in the drawings, and how to, I don't need the commentary, Demonte, or I'll turn you off. So, how to do the drawings and how to show the forces, okay? And I know there's different types of forces. You'll just have to use a little key to show it, but we'll do a couple examples. But here's a couple hints in the meantime, all right? So here's my hints. 1, if they're ions, so if it's not a molecular solid, if it's not something like ethane or water or whatever, if they're ions, for example, like Na plus, Cl minus, right? Stuff in table salt, then the anions, Tim H is here. Thank you, Tim. I'll check in a sec. The anions are always bigger than the cations. Let me sketch that in a second here. I'll get Tim. Good, I got my 2 Tims here. Good. Okay, so question for all of you. Anions are bigger. Why? Why? What do they got more of? Anions are bigger than cations. What do anions have more of than cations? Why are they bigger? I'm going to do an example here of this too. More electrons. Good. Kiara, Leo's got it. Alessandra, Aaron, and Isabel, and lots of you. Good. Okay. All right. And I need to know who Alicia is. Because I don't have an Alicia. Not in here. I do have Alicia. I'm sorry, Alicia. Pardon me. I forgot I got you in my 9E group. Alicia, thank you for joining us. Oh, and I got 2 more. Okay. I got Aslan as well. Okay. So here's an example. I would draw Cl minus like this. Cl minus. And I draw, if it was the same drawing, I'd draw Na plus like this. It's a lot smaller. It's got less electrons. It really affects the size. I know electrons are not big, but when they're added to the outside, it really makes the whole atom bigger, okay? Because they move around a lot, so they sort of take up a lot of space. So anions big, cations small. All right, my other hint. Draw more than 1 of each chemical. And finally, to show the intermolecular forces, you can show them with dashes or dots. Okay, intermolecular forces, we're going to abbreviate that today to IMF. I know there's different types. We'll review that in a minute. We're not there yet. I need you to be able to see that. There you go. Okay, so last thing, show the intermolecular force with dots like this or dashes like this. Okay, and then show covalent bonds the same way we always do, okay? With a line between them. Okay, so for example, if I have two H's, they've got a covalent bond between them, so I draw it as a line. Okay, let's see if I can move that over. It's a little less glare. Okay, so the last thing, if you can't read it, show covalent bonds with a line, example H, covalent bond H. Okay, all right. So that's the scoop. Intermolecular forces, we learned in our assignment that they're less strong. You know what I'm saying? So then I want to show that they're not a line, but they're just dots or dashes to show that lesser strength. So they're less strong than the covalent bonds. Okay. And I think I got everybody that's on there. Okay. All right. Good. Let's do a couple. Okay. And here's how this is going to work, folks. We're going to do a couple, and then I probably won't meet you the rest of the week. Instead, I'm going to assign to both classes an assignment of drawing a couple of these diagrams, and I'll just have you do it, take a picture of your work, and upload it into Google Classroom, okay? So that'll be our week. Next week, I don't know how much I'll be able to meet with you because we have MSAs 2 days, and we have 2 days of Klassenkonferenz, well, Notenkonferenzen. So I'm at school a lot of 2 days as well. I'll just have to look at what schedule time I have to meet with you. I'd like to meet with you at least once next week just to see how you're doing as well. Okay? All right? Okay. Hope everybody's got that. So there's my hints. Let's use them for a couple of pictures. Okay? All righty, dighty. And this is big stuff in 10th grade. You know, I teach 10th grade chem too. I'll be teaching it next semester to my 10E group. And you know, 10th grade is a lot of pictures and understanding what pictures mean. You guys are doing pretty good. You did good on the line drawings. You'll have those in 10th grade. And just lots of pictures of molecules. So you're going to be ready for this, okay? You'll be ready for grade 10. Okay, so here's my example. CaOH2 dissolves in water. Draw a picture. And describe the forces, I guess. Well, I'm going to write it out once. The intermolecular forces. Okay, let's say that was our assignment because it'll be really similar to what you're going to do, okay? All right, for fun, calcium hydroxide is what that we learned earlier this year? What kind of chemical is calcium hydroxide? What kind of chemical is calcium hydroxide? Good. Some of you got it already. Woo, quick. Isaac's quick and Inessa too. They're right. It's a base because it's got an OH minus. Ooh, a lot of you knew that. Thank you. It just takes a while for your responses to get, but I got Anton and Linus and Kiara and a bunch of you. Good. And Isaiah as well. Good. So it's a base. Let's draw this. So to draw it, I'm going to draw an imaginary big beaker. Ready? Plant, plant, plant. I know it's a really big beaker. And I'm going to put some water in it. Now, before I draw, I'm going to do some thinking. All right. If it dissolves in water, then what will I get here? What stuff will I get out of here? Can you see if you can understand this question? What will be in the water? What will come out of this thing? Hint, it will dissociate like acids. I'll get a solution, right? What'll be in this solution? What's going to come out of here? Not H, Leo. No, the H is not going to be alone there. CaO, no, not CaO. Don't take it apart, Alessandra. Keep it together. What sort of things are there? No, not CaO. I'm confused why you're saying that, folks. It's CaOH2. Okay, Isabella, thank you. So calcium and hydroxide. And specifically, it'll be calcium ion and hydroxide ion. So can you guys look up those ions that Isabella described for you? Calcium, what charge does that sucker take? Hydroxide, maybe you know that one, I hope. What charge does that sucker take? So can you type them down? Ca is what charge? OH is what charge? Close. You got one right, Isabella. Let's get some help from somebody else. So what charges are these? Hint, you can look at where Ca is on the periodic table. It's right here. So you can figure out what charge it is. There you go. Now she's got it. So does Inessa and Liam. Thank you for participating. So we got Ca and OH minus. So I'm just going to think about that. Which one's going to be bigger? What would my hints say? Which one do I draw bigger down below? Good. A lot of you got that. Thank you. Good. And OH minus. Which one going to be bigger down? Okay. A lot of you are saying it now. I think OH minus is bigger. Good. Right. So we're going to draw some OH minuses. Remember, we're going to draw at least a couple. I'm going to draw 3. So I got OH minus, OH minus. You know what? Do I want to draw it that way? Or do I want to draw little things for the molecules? Let me just think for a sec how I want to do this with you. I think I want to do molecules. Okay, so we're going to pretend that the molecules are like little balls. So we're going to do it like this. Okay, O, H. I'm just going to put a little minus here. And here's another one, O, H. And I'm going to do one backwards just for grins, okay? H, O, because they can flow around anyway, right? And I'm going to make a little key, all right? And my little key is over here. So this guy is an OH minus. Why do I know to draw it like that? Because it's got an O and an H, but they would both be atoms, so they're both just round, right? We know atoms are pretty much just little tiny round things. So there's my O, there's my H, and then just put a minus sign for that. Okay, then the Ca, you said this is big, so the Ca is going to be small. So I'm going to do the different color for the Ca. Okay, let's do that green. So I'm going to do this guy for Ca. And I'm going to label it 2 plus. And that's going to be Ca2 plus. There's my little key, right? Okay, so let's put some of those here too. Now I'm going to spread them out because you guys said it was a solution, some of you. So they're not going to be by each other now. They're going to be floating in the waters. So I'm going to do this guy. Maybe one in the middle. Can I fit one? Sure. All right. Now, In reality, I got a problem here. My picture should be electrically neutral. So check this out. Notice I got 2 plus 2 plus 2 plus. That would be 6 plus, wouldn't it? Now the other one, I got minus, minus, minus. That would be 3 minus. That doesn't add up. So actually, I got to add some more OH minuses. See what I'm saying? It should be electrically neutral. That should have been another hint. I forgot to tell you that. So I got to add some more of these. So I got to add enough minuses to match the pluses. So I need 3 more, don't I? So I'm going to put another one here. I'll put it backwards for fun. I'll put one down here. And I'll put one over here. Okay, now I got the same amount as negative as positive. So I got minus 1, 2, I got minus 6, and I got plus 6. So now it really is like it would be, except we're going to draw some waters. Okay, water is going to look like what? Water is going to look like H2O. And you remember we said water is bent? So to draw H2O, it's going to be, I'm going to do that in this black color. It's going to be these things. So it's going to be OH, like that. Now, before I draw the waters, we've got to do a little more thinking. Which side of the water was more negative? Remember, this is an O and 2 H's. Which side was more negative, the O or the H side? Who remembers? Which side of a water molecule is more negative? We say it has a negative pole. So where's the negative pole on water molecules? Super. Thank you for participating. Lots of good answers. Isabella, Kiara, Tim, and Tim H, and Felix, and Cassidy. Good. So I'm not going to draw it here because you know that now. Instead, I'm going to arrange them. So if that O side is the negative, I'm going to have the O side really close to some of these guys. So check this out. So the O is going to say, oh, I'm pretty negative. Ooh, look at that positive too. That looks sweet. I'm going to put my nose there. So we're going to draw the waters like this. Ready? We're going to draw it facing the 2 plus. Can I fit another one? No, I don't have a lot of room. I'll put some more down here. Maybe I can put 3 there. And I'll put the H's here away. Whoops. I can even fit another one, but I got a 2 plus symbol sitting there. I'll put some more over here. Whoops. Sorry. Rant. So I want the O side always facing the 2 plus. Do I got another 2 plus? I kind of did some of those. Okay, I'm going to leave this one alone because I don't have a lot of room up here. Okay, and looking at your comments. Careful, it's not O2H, it's H2O, Alessia. So I got 2 H's, that's the positive side, and I got the O is the negative side. Okay, remember these puppies here, these are my OH minuses. So this whole thing is negative. What side of the water am I going to draw facing the OH minus? Let me repeat that again. What side of the water molecule will face the OH minuses? So it will be the H or the O side of the water. Which side will face the OH minuses? Yeah, it's kind of complicated, isn't it? That's why we're taking time today to do it. Good, and some of you got it. Thank you. Thank you, Isabella, Inessa, and Alessia, the H side. So I'm going to draw some more waters. This time I'm going to draw them around my OH minuses, and I'm going to show them the opposite way. We say the opposite orientation. You ever hear that word, opposite orientation? So I'm going to draw some like this. I'm going to draw the O's or the H's because they're on the positive side. I'm going to draw them close here. So it's like Mickey Mouse's, right? So Mickey Mouse's ears this time are going to face the OH minuses. So Lots of Mickey Mouses. And here's some more over here, so I can draw a couple more. And have the ears facing the OH minus. Maybe down here too. And some more here. Yes, I know this takes a while. And we're going to finish our picture down here. Mickey's going to have his ears towards the OH minus. And here too. And one more. Good. Ooh, that's a lot of drawing, huh? Did I get Charlotte? I did not. Be sure you say hi when you come in. Okay, so let's make one last, while you guys are copying, let me just go run the list one more time, make sure I don't have anybody that hasn't said hi yet. 9E, you're pretty complete. I like it. I just missed Cassidy. Is Cassidy out there? And Ethan. Other than that, everybody in 9E is there. 9F, let's see how you're doing. Also pretty good. 9F, I'm looking for Sophie, Avram, Allie, and Michael. If any of those are there, let me know. Cassidy is here. I see her. Thank you very much, Cassidy. You snuck in and I didn't see. I don't always catch everybody's name. It's a big list of students. Thank you. Okay, so questions on how to do this. It's a pretty busy drawing, isn't it? It's got a lot of details. But you know what? This is how it really looks. This is how chemists think it really looks in the water. Now, if I put my hand in and swish the water, oops, not my leg. If I put my hand in and swish the water around, these ions would probably break apart from the waters, but then they would reform into something really similar to this. So this is really how the picture looks. Now, let's write what sort of interactions we would have. What sort of force is between the dipoles of water and the ions? And I'm going to read your comments now. Okay, why are there only 3 and sometimes 2? Because I can't always fit them in my drawing. In reality, here's where my drawing, Kiara, is not perfect anyway. In reality, I would also have 3 dimensions, wouldn't I? So wouldn't I have waters not only here, but I'd have them outside here in the air facing the, so I'd have like one here facing the OH minus, I'd have one behind it. So my drawing is also not perfect. Okay, and Devante says Lunde dispersion forces. No. No, it's one of the forces that was on the worksheet that I gave you, right? Think of what's there. Look, I got charges here and I got something with a dipole. So kind of put it together. What sort of forces are there? Yeah, Alessia, right. The OH minuses are attracted to the H2Os. They're not really mixing, they're attracted. So there's the OH minuses and the waters are attracted there. But what intermolecular force is that called? Okay, and I got Avram here finally. A little late. Avram. Yes, water, Alessia, right, has a permanent dipole. So that might be in the type of force. I know you're new to this, but it's on the sheet I gave you of the different types of forces. Well, what do I got here? You can just about look at the picture and see. Dipole's part of it, Leo, yes. But what's it attracted to in my picture? What are the dipoles attracted to? Hey, Cassidy's got it. Thank you. So does Isabella. Okay, so the ions are attracted to the waters here with, big surprise, ion dipole forces. Ta-da! Did I say this is hard? It's not. So if it's between ions and a dipole, it's called an ion dipole force. Cool, huh? Not so hard. Okay, that's one of our pictures. How are we doing on time? We're doing okay. Yes, Aaron had it as well. As did Isaiah and Ingrid. I'm going to erase this, so let's see if you got any questions before I do. Let's see if you can read that over there, okay? So ions are attracted here to water with ion dipole forces. That's what we drew. And look at what I wanted you to do. It says, draw a picture and describe the intermolecular forces. So we now have done that. There's our picture. There's our description of the intermolecular forces. Okay? Are we good? That is the sort of thing I have my advanced students do and my 12th graders, okay? So this is real stuff. This is the way people think it looks. Good. All right. And I'm going to erase. And if those that came late couldn't get it, you'll have to watch the video to get the drawing to write it down. Let's do one more example together. Okay, let's do this one. Water and ethanol. And ethanol looks like this. We had it, but I'm going to tell you just again, I got to draw it bigger than that. Sorry. So it's got H, 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 and then another C with an OH, and then an H and an H. So water and ethanol mix well. So draw a picture and explain. You guessed it, Chester. Explain the intermolecular forces. I'm going to abbreviate that now, IMFs. I use plural just because there's more than one particle, all right? But it's usually one type of force in the picture. All right, let's do our giant beaker again. Okay, this time I'm going to start with the one we know. Okay, here's my key over here. I know that my water is going to look like this. So let's just draw some waters. Let's draw like 3. All right, let's draw 3 waters. So here we go. Shaboom, shaboom, shaboom. Shaboom, shaboom, shaboom. Notice I'm drawing them random, aren't I? I'm not always putting the ears, the H's on the same side, okay? So sometimes I put Mickey Mouse ears up top, bottom, because that's the real world. The waters are randomly in there. Okay. Now we got to do some thinking before we do our drawing. Alessia, I don't know if I'll have time or not. If I don't, you're going to have to write me and ask me in an email, but then I can answer you because I don't know if I'll have time to get to the homework today. It's not looking like it. Okay, ready? Here we go. Up here, check out what we got. Aha, I got as part of this molecule, part of it's just some C's and H's. That's really uninteresting, but this part's interesting. Oh, I got an O and an H. An O and an H. Hint, who remembers this? H just wants to have fun, right? H just wants to have fun. So what's going to happen here? If I got an O and an H, who ends up being more positive, who more negative between O and H? Who ends up being more positive, the O or the H in this molecule? I'm just talking about one ethanol here. Which atom is more electronegative? Thank you, Isaac. Righto. Good. Thank you. Lots of correct answers. Linus, Paul. Good. So the O is more negative. I'm just going to put that in my little picture. The H is more positive. Okay, so for the picture, I'll do my alcohols in blue. So my alcohols are kind of big. I'm going to do one sideways. So I've got a C, and I got 3 H's, and then I got another C, and I got an H, and then I got an OH. Ooh, that's hard. Maybe I better do the O in a different color. That might be clever. So here's the O, and there's an H. All right, that whole thing, believe it or not, is my ethanol. And ethanol is C2H5OH. If you want to know as a formula, that's not so important for you and I. What's important is, how do I draw these suckers? Okay, so here's a water. Which part of this thing, the H or the O, is going to want to face the O here? So here's the O side. Which part of the ethanol should snuggle up to this O side of the water? Did I forget an H at the second C? No, there's an OH there. CHH there. Did I forget one here? Oh, you guys are good. Thank you. Thank you very much. Well done. Good eye for details. I like it. Okay, so yeah, the H. Good. Okay, so here we go. Here's how we're going to draw this. So start with the one that's going to be close. And then draw the O attached to it. And then draw the rest of the sucker, like going away. So the rest of it is my 2 C's with 2 H's there, thanks to all of you, and 3 on the other one. That's how it's going to look. So that's kind of the way it's going to sit there. And then same with another one. Let's put another one here. Actually, I take it back. Let's put another one up above. And the other one up above, I'm going to have to draw it a little differently. The other one above is going to have, this is positive, right? So it's going to have the O more attracted here. So it's going to sit a little differently. So the O is going to have to be there. There's the H. Oh, yeah, that's right. There's the H. And then going away from this will be the C's. Okay? So for each of these, try and have at least a couple molecules. One of them so that the H is facing this and the other the O. And ideally, I didn't draw this one perfectly. Ideally, the molecule would be bent here, kind of like I did here. The OH is bent, but it's okay. I'll try and do better on my next one. Okay, so down here on this side, this side is positive, so I'm going to draw the O here first. And then I'm going to draw the rest of this, not so close. So there's my H, and there's the rest of this thing trailing off, my two C's. But on the outer side, okay, I'm going to have the H up close. And then I'm going to draw the O away from that. And then I can draw the rest of that coming off some way or other. Here's my two C's with the H's around it. And I'll do one more down here because we're running out of time. I know time flies. These things take some time, don't they? So here's going to be here's going to be the H, and here's going to be the O, and here this one's going to be the O, and there's going to be the H, and then the C's coming off here. Boom, boom. And down here, I can just put the H's, the C's coming away. Boom, boom. But this is how they think this works. And as you're writing, can somebody punch in? Hi, Ellie. You're going to have to watch the video. You missed most of it at this point. I can't give you credit. Okay, so for everybody, what's the intermolecular force here between the alcohols and the waters? So the intermolecular force between waters and ethanols, I don't need plural there. How about to say water and ethanol is, see if somebody's got it. What's intermolecular force is this? Hint, H just wants to have fun. Which force did that refer to? Look back on your notes or look on the homework assignment diagram that I gave you. What sort of forces between the waters that have H2O and the ethanols that have an OH on them? Dipole is wrong. Ooh, and Aaron has almost got it. Aslan, there you got it. Okay, it's hydrogen bonding. Bang, 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 bang. Why? Because hydrogen bonding has to do with hydrogen being attracted to F, O, or N. And here it's O. I got a hydrogen attracted to O, and I can put little dashes here in green. Boop, boop, boop. Boop, boop, boop. Boop, boop. Isn't that cute? Boop, boop, boop. Not much. There's not a lot of room, is there? Boop, 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 boop. Okay, so is hydrogen bonding. I know it's not a bond. Remember, it's just an attraction, but it's called hydrogen bonding, or in German, Wasserstoffbrücken. Good. That's it. Questions from you? Thanks for getting up so early today. And I'm going to give you an assignment that will have you draw a couple things like this and describe the bonding for the rest of the week. And that'll put you in good shape for 10th grade. Well done. Thanks for everybody's participation today. I wish you a good, healthy week. And I'll send this video out to those that either got here really late or just didn't show up, okay, for whatever reason. All right. Bye-bye. Stay healthy.